Hi, everyone. Welcome back to the Statistic lecturing series. We are still in the unit Introduction of Probability. And on the video number 1, we finished give the basic definition about a sample space and events. So in this video, we're going to talk about events operations, the union, intersection, complement, and also we're going to talk about the Venn diagram, how to use the Venn diagram concept to represent the events operations. Okay, so here, this is what we did in the first video. We did 4 practice problems here. And then for this videos here, we also have like 4 problems for us to do. And okay, and let's start. So let me go back to the whiteboard here. Okay, so here is the whiteboards here. And all right, so like in this, in this unit, in this lectures, we're going to talk about the events operations, right? So first, let's say, try to review what we did in the first video. We said event, we use capital letters and try to represent it, right? Okay, so the union, the notation for the union is like this. And the intersections here is like this, right? The complement, some book use like a prime here, and it's not that big a prime, it's like, okay, some book they use like a prime, and the some book they use the word C, and it depends on the different textbook. So what is the event operation? Like in the real number, we add the numbers, we multiply the numbers, we divide the number. So the events operation is similar, like that's why we call it operations. So that's why we try to combine the different events. Okay, so what is the unions here, all right? So the unions here, so like, so basically, it's like we said, combined events elements together, right? So if you event, so we use this notation. We say A union B here. Okay, that means I'm combining both the elements in A and the elements in the B. So here we combine the elements together, so we do not repeat the common elements. Okay, so we don't repeat the common elements. So what's that mean? So let's take a look at examples here. Okay, so examples of A is here. If I have the number 1, 2, 3, 4, and A, B, C here, right? So this is my event A. Let's say the event B is here. This will be 2, 3, 7, 9, B, and the EF here, right? Okay, so we try to do the A union B. So basically, we just put all the elements together. So we will say the 1, 2, 3, 4, A, B, C, right? Then for the B, the 2 I already put in here, right? 2 I already put in here, so I don't repeat it. So that's why 2, 3 I already put in here, so I don't repeat it, right? So the 2, 3, 7, 9, and the B, I already have the B, so I don't repeat that. So, and this is the EF here. All right, so that's what we call it is the unions. Here you combine the same elements, right? You combine all the elements. If the same elements, you repeat the common elements, you don't repeat, you don't repeat that, you don't double that, right? Okay, so what is the intersections here? Okay, so intersection is basically is find what? Find the common elements. Okay, so what I mean from the common elements here, that means in here I use these notations, right? So A intersect B is upside down use, right? So this is a union, and this is intersect. And then in here, so A union B, if we still use this example, A union B, what are the common elements here? We have the common elements. 2 is a common one, 2 is a common one, 3 is a common one, 3 is a common one, B is a common one, B is a common one here, right? So the A union, A intersect B, and we call this the common elements. So what is here is 2, 3, and the B's here. And that's why it's A and in the B's, right? So that's why typicals here, you know, sometimes when you work on the problem, they're not going to tell you find the intersection or find the union. So you need to read the problem and understand, am I finding the intersection or am I finding the union? Because see here, this is A and the B's, right? So the common elements in both. So most likely, if you see in your problem statement, if you see the keyword and, that means you probably need to use intersections here, all right? Then union, we say, is like you put the A and the B together. So it's either A or B's, right? So the keyword here for union is what? Is or. So when you read the word problem, if you see or, that means probably you're looking for the what? The unions here, okay? Now, the last operation we call is a complement. Okay, so complement, so is basically is elements not in the set. Okay, so like the complement is like when you look at the whole sample space, it's not in the set. Typical, like I said, you can use this notation, A prime, all right? So that's the notation some book use, or some book they like to put like this, it's a little c's here. It's a complement here, right? So the complement, that means everything is not in A. So let's take a look at these examples here. Let's assume, you know, the example, they only give us A and B. Let's assume the sample space is like 1, 2, 3, 4, okay, and 7, 9, A, B, C, D, E, and 10, 11 here. So let's assume the sample space is like this, right? So what is the complement? That means A prime is everything in the sample space, but not, right? So the keyword here is not, right? It's not in A. So let's see it here. The A complements here will be, right? So A is 1, 2, 3, 4. So I cancel 1, 2, 3, 4, and the A, B, C. So A, B, C, right? So those are the value in the A. So the A complement will be the remaining. So it's 7, 9, what? 7, 9, D, E, and the 10, and the 11, right? Okay, so these are the 3 operations. It's a very super easy operation, union, intersection, complements here. And sometimes we can use a graph, just like in algebra, but you're learning from algebra, you have a function, you have a graph. So here we can also use a graph to represent those, those operations. So we call it the Venn diagram. So typical in the Venn diagram, okay, so let's take a look at unions here, the Venn diagrams here. Okay, so typical in the Venn diagram, we use a rectangle to represent the what? We use rectangle to represent my sample space here. And then for the events, I use different circles here, right? Okay, so let's see here. So like event A is here, right? I use different color. Then event B is here. All right, so this is event B. So A union B, just like we said before, is what? You put the A and the B together, right? So like it's A or B. So this shaded area, if you use Venn diagram, that is what we call is A union B here, all right? Then the next one, A intersect B, still you use a rectangle to represent the sample space here. And this is my sample space, right? And now you have A is here, and you have a B, right? So the B is here. I need to get a little bigger. Oh, well, so let me erase my A also. That's not nice. Okay, so here this is A, and then this is B, right? So A intersect B, that's what we say is the common area of A and B, right? So where is that? This one's here, right? So this is the part belong to both A and B here. Okay, so now let's take a look at complements. What that means here. So if this is the sample space, right? So this is the Venn diagram sample space. Now, if I have A's here, right? So this is my A. So what is the A complement? Is everything inside the sample space, but it's not in A. So this is what we call the what? So the blue area, that's what we call is the complements. Okay, so that's the lecture about the events operation and the Venn diagram. Right now is a good time to pause the video and then go ahead to practice the 4 problems I have on the next pages here, right? So go ahead to try to practice it. And then after you finish practice and come back and resume the video and come to check the answers here. All right, so if you want to, you can pause it. Okay, so now let's take a look. Okay, and let's take a look at the problem number 5. Okay, so the first problem they ask you is use the Venn diagram to verify 2 De Morgan laws. De Morgan laws, this is kind of like it's kind of like right. So this is the it's kind of like equation. So basically, the De Morgan laws tell you, say, if you do A intersect B, the complement will be equal to the complement, then you flip the intersection, become the union. So the same way is if you union the 2 events, then you take the complement, it will be equal to, you take the A complement, then you flip the union, become what? Intersection. It's a very similar like in the real number, in the algebra, we call these distributive rules, right? So you move the things inside the parenthesis. But in the set theory, we call this is De Morgan laws, right? So you intersect the first and then you take the complement will be equal to, you take complement first and then you union, you flip these operations, right? You flip the intersection become union, or you flip the union become intersection. Okay, so in here, they say use the Venn diagram to show this, right? So let's take a look here. So this is the Venn diagram, right? So my A is this one, and the B is this one, see here, right? Okay, so this is a B, this is A, okay? So let's do the right-hand side and do the left-hand side. We do the left-hand side first, then do the right-hand side to see the equal now. Okay, so take a look here. This is A intersect B, right? So A intersect B, where is A intersect B? Is a common part, right? So it's here. All right, so this is here. Then they say, after you intersect, you find a complement. That means what you do, you find everything else except that. So for my left-hand side, my solution will be the area I graph it in what? In the blue colors here, right? So it's everywhere outside except that little yellow spot. Okay, so now let's take a look at my right-hand side. It's giving me the same things or not. All right. Okay, so my right-hand side, this is my A. Okay, and then this is my B's. All right. So the first things they say is A complement. So the A complement will be everything outside A. So it's here, right? So I just use the same. So I color coded that. That's what is A complement. And what is a B complement? B is everything outside B. So here, this is the B complement. Okay, so then they say you union it. That means you combine the green arrow and the purple shaded area. So if you cover the green and the purple shaded area, what do you have here? So this is your final answer, the blue ones, right? Right, so that's what is your camera answer is blue one. So it's the same thing, same blue area like we did on here. That's how do we prove the De Morgan theory by using the Venn diagram. See here, the blue is my final answer, light blues, right? So the light blue is everything except this little part here. So the same way is in here, the light blue is everything except that little part. Okay, so now let's take a look at this one, the second De Morgan series here. So this is A union B's, right? Okay, so let's see here. So this is A, and this is B's, right? Okay. So the first things here, A union B. Remember the A union B? You just combined A and B together, correct? Okay, now you take the complement. So let's see, where is my final solution? That means everything outside this yellow area. So here, this is my final solution, right? So this is a blue area. So what is my final solution? So it's everything outside these two circles, right? Okay, now let's take a look here. Okay, so here, right? So my A is here, and my B is here. Okay. So now the first thing is they say A complement. So it's everything outside A. Correct? Okay, so I use the color coding here. And the B complement is everything outside B here. Okay, now in here, we say A intersect B. That means the common part of the green areas and the purple area. So which part is have area both green and purple here? Right? It's outside these two circles here. So that's what is the A intersect A complement intersect B. So we know that's how do we prove the De Morgan theory by using the Venn diagrams here. All right, okay. So now let's take a look. All right, so this one, so this the problem number 6 should be pretty easy also. So the S is sample space is 1, 2, 3, 4, 5, 7, 9. A is here. Okay, so the first thing is here, I'm going to find A complement. So let's try to write it down, A complement. A complement is everything not in A, but it is in the sample space. So it will be what? So it's 2, 4, 6, and the A and the 9, right? Those are the values inside the sample space, but not in A. Okay, so then the B's here we have is 6, 7, 8, 9. So far, so good. And now they want to find the intersections, right? That means the common part. So let's see where is the common part. Hey, the 6 here, 6 here, A here, A here, 9 here, 9 here. So those are the common part. So that's what I get my answers here. A intersect B is equal to what? 6, A, and the 9, right? Okay, now the next one's here is B complement union C. So let's try to write out what is my B complement first. B complement is everything in the sample space, but not in B. So you look at the sample space. So it's 1, 2, 3, 4, 5. Correct? That's B complement. 6, 7, 8, 9 is in B, so I cannot include. Okay, union C. C is 2, 4, 8. So we know the union is combine them together. If they have the repeat, you don't, if a common elements, you don't repeat. So it's 1, 2, 3, 4, 5, and what? And 8, right? Okay, good. Then you intersect D. D is 1, 5, 9 here, right? Okay. Now you intersect. That means you find the common elements. Hey, what is the common elements here? 1, 1, 1 here, 5 here. That's it, right? So that's why I know my common elements here is what? My common elements. So my final answer is B prime union C intersect D is equal to what? 1 and 5, right? Okay, so it's pretty simple examples. I hope you got it right. And so this will give you a very basic idea how the events operation work. Okay, so now let's take a look at our next problems here. The next problems here to tell you if the sample space X is from 0 to 10, then the M is from X3 to 8. X is from 3 to 8. And the events N is X is from 5 to 10 here. Okay, so first thing here, they want to find M union N's, right? Okay, so here, in order to do this ones here, let me try to here. Okay, so this is my sample space. Okay, so let's say the sample space here, this is 0, and this is 10, right? So my sample space X is from 0 to 10. Okay, then the M, I'm going to write it. The M's here is from 3 to 8, right? So it's 10, so this is 5 somewhere. So the 3 probably is here, and 8 probably is here, right? Okay, okay, so M, I'm using the purple color, is from 3 to 8. Okay, 3 doesn't have an equal sign, so this is my event M from 3 to where? 3 to 8, right? So this is my event N. Okay, now my event N is from 5 to 10. 5 is here, right? So it's a circle to 10, right? So this is my event N. Okay, so now we said, let's try to find M union N. That's okay. So M union N, that means you combine the area of the purple and the green. So M union N, so how do I write it? I would say this is equal to X. So what is the value of X? The X is started from 3, right? So it's X less than 3, and all the way to where? All the way to what? All the way to 10. Got it? Okay. Now, the next ones here is M intersect N primes, right? Okay, so be careful here. This is N primes here, right? So I'm going to do N prime first. N is here, right? N is my green. So N prime is everything else in the sample space except N. So here, because here is a circle, so this is a solid. So it's from here to here. This is my N prime, correct? Right, so it's inside the sample space, but everything else except, the elements in the N. Okay, so now let's take a look here. So this is the intersection. That means I want to find the common area, common area, or common overlap between the M and between the purple and the orange, right? So here, this area is kind of like, this areas here is kind of like is our common areas, right? So what is my answers here? Okay, so its answers here is, so this is a common area because this ones here is circles, right? So I have a 3, x is less than 3, but here this is solid, so that means I need to include it. So it's what is equal to 5. Okay, so this one is pretty, this kind of is a little bit different, but I think this one is interesting. So you need to be careful about the one with equal sign or not equal signs, right? Okay, so now let's take a look at number 10 here. Number 8, I'm sorry. So number 8, we said I have a group of 200 college students. All right. So let's see here. So let's say here, this is my okay, so let's say this is my sample space here, right? So this is my sample space. All right, so I have 200 college students. Then the 138 of them enrolled in psychologists, right? So let's, I use this ones here. This is a psychology class, right? Okay, then 115 enrolled in the sociologies, right? Okay, so now I have this circle, yes, sociology. Okay, so then let's say I have 91 enrolled in both here. Now I want to find out how many of the students not enrolled in either courses here. So the way we do Venn diagram, we always start with the smallest area. So the 91s here, right? So this is the one enrolled in both. That means I know that here is the 91. The both here, that means the intersections, right? Remember we said that they're not going to tell you which, so you know, okay, so this area is 91, okay? Right, so this orange area is 91. And I know the psychology is 138, right? So the psychology is 138, but the 91 of them also have the sociology. So how many left here? So you are going to have 47, right? Correct? Because the 47 plus 91 is equal to 138. So the whole psychology circle is really include those two numbers, 47 and 91. So now the same way, let's take a look at the sociologists here. So I have 115. So I have 91 here. So how many is here? I have 24 here. So because here I know the 24 plus 91 is 115, right? So 115 is a student taking the sociology. But so the way I color, like, so the 24, what does 24 mean? 24 really is meaning is, that means is what? The student take only sociology. Then the 47 is what? Is the student, they take only the psychologists here, right? But then if you combine, we have 138, they take us, the psychology, but the 91 of them, they also take the sociologists here. Okay, so now the question asks us, how many students are not enrolled in either of the course? So what's that mean? That means that I'm really looking for what is not in either one, in either one of this. So that means I'm looking for here, outside these two courses. That means those students are not enrolled in either one of them, right? So how do I find the numbers here? I know the total is 200, right? Then you can minus, okay, so basically you can do is you can minus those three pieces. So you minus 47, minus 91, minus 24. So that will give you the outside of my light blue colors here. So it's 38. So that means outside this area, I have a 38. So that means here I have 38 out here. That means this 38 is not in the psychology, not in the sociology, maybe in some other classes here. Okay, so that's it. And so those 4 problems are not too bad. And I think most of you should get it. All right. And so that's it for this video. And then we're going to talk about some probability rules in our next videos here. It is very nice to talk to you about this topic. If you find this topic is interesting, feel free to subscribe to my channel, all right? And also, if you have questions or something you're not clear, feel free to leave me a comment and I will answer your questions here. Okay, so it's so nice to talk to you, and you know, hope that you learned something about the events, and I'm so looking forward to talk to you in our next videos here. All right, that's it, and bye, and have a good day, and talk to you later. All right, bye-bye.